Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 4 from the May-June 2024 Cambridge 9709. This is the mechanics paper 4 variant 2. And here we have a question about a car which has a mass of 1400 kilograms, 1400 kilograms. When the speed of the car is v meters per second, the magnitude of the resistance to motion is kv squared newtons. So the magnitude or the resistance to motion is given by k times v squared. This is the the resistance depending on the speed here. All right, where k is a constant. So k is a particular value which we probably have to find, which we do in part 1. So they gave us some information. The car moves at a constant speed of 24 meters per second up a hill inclined at an angle of alpha to the horizontal, where sine of alpha is 0.12. At this speed, the magnitude of the resistance to motion is 480 newtons. Find the value of k. Okay, so basically, we know that the resistance to motion is 480, and we know we don't know k, we have to find it, and we know it's going at a constant speed of 24, so this is going to be k times 24 squared. So r equals k times v squared. So that means k is going to be 480 over 24 squared. Okay, so we'll find out what that is. So you have 480 divided by 24 squared, which gives you 5 over 6. So k is equal to 5 over 6. I'll leave it as an exact fraction, that's fine. So k is equal to 5 over 6. That's part 1 done. Then it says, find the power of the car's engine. So we got to consider that it's on an inclined plane. Okay, so it's on an inclined plane. Okay, and it has a mass of 1400 kilograms. So basically, its weight acting vertically downwards is going to be 1400 G newtons. Okay, so that's going to be 1400 G newtons acting vertically downwards. Okay, and you also have, we've got to think about the component of the force acting parallel to the plane. So I'm going to think about this. This is perpendicular to the plane. All right. And we know that this angle is alpha, therefore this angle is alpha, angle to which the weight is compared to the normal will always be equal to the angle of the incline of the plane. That's due to similarity of these two little triangles here. So now that's alpha. So the component of the weight acting down the plane, parallel to the plane, is going to be this component here. That's 1400 G sine alpha. Okay, and it has a driving force. Okay, which we know is going at a constant speed. So there's a driving force pulling it up that way. Driving force making it go up the hill. So I'll call that D. And you have the resistance force acting in the opposite direction, and we know that that resistance force is given by 480 newtons. They told us that when it's going at this speed, because it's going at this constant speed of 24 meters per second. All right, so that's the situation with this. So we need to find the power of the engine. Okay, so to find the power of the engine, we know the power is equal to the driving force times the velocity. So we know the velocity, we need to find the driving force. So we know it's going at a constant speed. Okay, it's going at a constant speed. So we know that the resultant force is equal to 0 because it's going at a constant speed. So we can say if we resolve the forces up the plane, that D is going to be the same as 480 plus 1400 times G times sine of alpha. Okay, and we know that D that's 480 that's 14, and then you're going to have 3 zeros, okay, because G is 10 times 0.12, so that's going to be what? So you have 480 plus 14, and now you're going to have 1000 times 0.12, because sine of alpha is 0.12. And that gives you 2,160 newtons. That's the driving force, which means that the power of the car's engine is 2,160 times 24. Okay, that gives us what? Times 24. That gives us 51,840 watts. So there's your answer to part 2 of the question. Okay, how do we know that the driving force is equal to these two? Because it's going at a constant velocity. The resultant force is equal to 0. So the driving force is equal to those two. Okay, and so that is the answer to part A, part 2. Then we've got part B. It says the car now moves at a constant speed on a straight level road. So now the situation has changed. It's now going on a level road. It's no longer going up an inclined plane. Okay, so it's now going on level road. Its mass, of course, didn't change. It's still 1400 kg. Okay, but now the engine is working. The power of the engine is 54 kilowatts. So now the driving force, we're going to find the speed. We've got driving force, and now we've got the resistance to motion. Now it's going at a constant speed. Okay, so the resultant force again is equal to 0. So we can say that the driving force is equal to the resistive force, right? And we know that the power is equal to the driving force times V. So the velocity is equal to the power over the driving force. Sorry, is equal to. So we can say that the driving force is equal to the power over the velocity, over the speed. And we know that the resistance to speed is given by the formula kV squared, as we learnt in the beginning. Okay, and we know that K is 5/6. So the resistance to motion is given by 5/6 V squared. So I know that these two are equal to each other. The driving force is equal to R. And we know what P is 54 kilowatts. So we can say this is 54,000 over V is the same as 5/6 V squared. So if you rearrange this equation, we're going to have 54,000 times 6 is equal to 5V cubed. So therefore we can say V cubed is equal to 54,000, okay, times 6 over 5. So V is going to be the cube root of all of that. So we take this, the cube root of, and we're going to have 54,000, 54, 1, 2, 3, 1, 2, 3. Okay, times 6 divided by 5. The cube root of that, and that gives us 40.165 meters per second. So V is equal to 40.2 meters per second in 3 significant figures, as we should round non-exact answers. So there's part B done. Okay. So again, we use the fact that there's a constant speed, which means that the the resultant force is 0. So D and R must be the same. This is called dynamic equilibrium. It's moving, but the forces are in equilibrium. And so we can then work out an expression for D in terms of V, because we know the power, and R in terms of V, because we know the resistance is 5/6 V squared, and they must be equal to each other, so we can work out what V is. Right, so there's the answer to part B. Is there a part C? No, that's it. That's 4A and B. Okay, so that concludes this question number 4 from the May-June 2024 paper, Mechanics M1 from Cambridge 9709. Other questions from this particular paper can be found in the playlist that will appear on the top right of the screen at the end of this video. Other questions from the topic of, this is to do with basically power and also something to do with inclined planes. I'll put it in there as well. Okay, and forces as well, I guess. So I'll put a few different playlists here to give an idea of different topics which have the same kind of concepts. Thank you for watching. See you soon.